Hey, we're back for this. And just if we're going to continue talking about the electric field here, let's remember how we draw electric fields, right? So for a point charge, we would talk about the electric field definitely pointing radially away from the point charge. That's what I'm trying to do here as best I can. Um, and then one of the things you'll notice is that as we get farther and farther away from the point charge, that the electric field gets more and more spread out, right? So what we would say is that that's an indication that the electric field strength is weakening as we're getting farther away. So as we move in closer and closer to the point charge, you can see the field lines get closer and closer together. So that's what lets you know the electric field is getting stronger and stronger and stronger. So it's more and more difficult to push the test charge against this electric field the closer we get. If we were to draw a picture of the electric field that exists between the plates, that would look a lot more like this. Let me try and just do it this way. So for here, we'd have an electric field that is a lot more consistently spaced. Let's get a couple more. That should do it. And so here, this would be a picture of the electric field that exists between the plates. And you can see that as we move our test charge through this field, as we move, we're not getting any closer or any farther from the lines don't get any closer or farther from each other as we move through them. And so sort of the analogy for this would be this image is the one that we would use if we were going between like the ground and the ceiling in a room, right? Because we take that the gravitational field is constant. So anywhere in here, we take G to be 9.8 meters per second squared. If we talk about finding gravity from a planet, then we understand that moving farther and farther away from the planet, the gravitational field gets weaker and weaker and weaker. So one of these is used for when the field is constant, and one of these is used for when the field is changing. So let's talk about what electric potential is, which is what voltage is. And it's similar to electric potential energy, but it's actually the work done, which would be the energy, but it's specifically the work done per unit charge against the electric field. And it's this part here, this per unit charge part, that makes it so special, or it can sometimes cause some wrinkles for people. So the idea of having work done per unit charge, that's what voltage is. And so the units for voltage is a joule per coulomb, or simply you'll see it written as a volt. Now, another way to think of this is it's also thought of as potential energy per unit charge. So voltage is the amount of potential energy an electric charge has per the amount of charge. Or you'll see potential energy is voltage times the charge. So look, the whole point of this is that electric fields change a lot more than gravitational fields, which is why it's important to know the amount of energy involved. And in order to know the amount of energy involved, we need the charge that's associated with it. So that's why voltage is a useful term for electric associated with electric fields. But the point of this really is if you understand potential energy, you understand voltage, or what is called electric potential. Yes, it's actually energy or work done per unit charge. So it's instead of being joules, it's joule per coulomb. But if you're ever stuck on what you think the answer is, just think of what you know about potential energy and then just apply that, because about 99 times out of 100, you'll be just fine. So looking at this, we talk about two equations for voltage. One is V equals ED. This would be voltage between plates. Again, this is taking the E field to be constant. And another one would be voltage from point charge, and that's KQ over R. And here, this Q can be positive or negative. You're supposed to use the sign of the charge because voltage is a scalar. And the reason those two equations are different between the plates and the point charge is because for plates utilizes a constant E field, which we saw in our last drawing. All the field lines were spaced evenly. And for point charges, the E field varies as 1 over R squared, which explains why the electric field is not consistent in that case. And so those are the two equations you need for any voltage problem you're going to see. And you just have to recognize the difference between whether it's between plates or constant or whether it's from a point charge. As long as you can tell the difference, you should be fine.